All right, today we're diving deep into one of Terraform's most powerful, but let's be honest, often overlooked features, parallelism. This is really the secret to unlocking some serious speed in your infrastructure deployments, and we're going to show you exactly how it all works.
I mean, we've all been there, right? You're just staring at the terminal, watching the cursor blink, waiting and waiting for Terraform to finish doing its thing. That lost time, it really adds up, and it can be a major source of frustration for the whole team.
But what if you could actually take the wheel and control that speed? Well, that's exactly what this explainer is all about. We're going to pop the hood, see how Terraform decides what to build and when, and give you the tools you need to tune your workflow for maximum efficiency. So to get a handle on Speedy, you first have to understand the structure. And the key to all of this is something called the dependency graph. You can think of it as Terraform's engine room. It's where all the critical decisions get made before a single resource ever gets created. So what are we actually controlling here? Well, Terraform parallelism is really just the number of things, like creating, updating, or deleting resources, that it can do at the exact same time. And you should know, out of the box, Terraform sets this number to 10.
Right, so before Terraform does anything, it scans your code and builds this dependency graph. The construction blueprint analogy is perfect. A good construction crew knows you can't put up the walls before the foundation is bored. This graph tells Terraform exactly which jobs can happen all at once, and which ones have to wait their turn.
Okay, to really see this in action, let's compare two really simple scenarios. First up, we've got 5 resources that have absolutely nothing to do with each other. Then we'll take those same 5 resources and link them together in a chain. The difference this makes is, well, it's staggering. Okay, so here's our first setup. It's just 5 simple random string resources. And the key thing to notice here is that there are no references between them. They are completely self-contained. Each one is basically an island.
Now, what's so cool is what this does to that dependency graph we talked about. It makes it flat and wide. See, because no resource depends on another one, Terraform realizes it can create all 5 of them at the exact same time. This is the dream scenario for speed.
Now for our second configuration. All we've done is add one tiny little thing to the code, the depends_on meta argument. We're literally telling Terraform, hey, don't you dare create word 2 until word 1 is finished, and word 3 has to wait for word 2, and so on down the line. And boom, just look at the impact. The graph isn't flat and wide anymore. It's this long, sequential chain. Terraform has no choice here. It has to create these things one by one. Our potential for parallelism has just cratered, and it doesn't matter what flags we set. Okay, so now that we get the what and the why, let's get to the good stuff. How do we actually take control and start tuning this behavior for our own infrastructure code? You basically have 3 primary levers you can pull. The first, and by far the most important, is just managing your resource dependencies. The second is using that command line flag. And the third, for those bigger, more complex situations, is splitting up your configurations. Let's just be crystal clear about this. The number one thing that influences your deployment speed is the structure of your code. Before you even think about flags or any other tricks, you have to audit your configuration. Ask yourself, are there any dependencies in here, explicit or implicit, that I can get rid of to help flatten out that graph? Now let's talk about that parallelism flag. This slide shows you the impact perfectly. On the left, with parallelism set to 1, Terraform creates a resource, waits for it to finish, and then starts the next one. But on the right, with parallelism set to 5, it just fires off all 5 creation requests at once. The difference in actual time you spend waiting can be absolutely enormous. And finally, if you're wrestling with a truly gigantic, monolithic configuration, the best long-term play is often to just break it apart. When you split your infrastructure into smaller, more manageable, and independently deployable chunks, you get the amazing ability to run multiple Terraform apply commands at the same time. Okay, so we've got the basics down pat, but performance tuning is full of nuances, right? So let's get into some expert-level tips and a few common traps you really need to watch out for. Now, for something that is absolutely crucial to remember, Terraform doesn't live in a bubble. It's talking to a cloud provider, and that provider has its own set of rules. One of the most important is the API rate limit, basically a hard cap on how many requests you can throw it at it in a short amount of time. And this quote from the source material just nails it. You can set parallelism equals 200 if you want, but if your cloud provider only allows, say, 20 API calls per second, then the provider becomes your bottleneck, not Terraform. Pushing it too hard can actually slow you down because the provider will just start throttling your requests.
And this all leads to a really critical question. Is just cranking up that parallelism setting always the right move? I mean, it feels like it should be, but the reality is a little more complicated.
You have to check out this fascinating test from the source. It was timing the creation of 5 very large random strings. And this is a task that happens locally, on your machine, not in the cloud. With parallelism set to 1, it took about 14 seconds. Now get this, when they set it to 5, it took almost 23 seconds. For tasks that are heavy on your CPU, running them one by one can actually be way faster than having them all fight for computer resources at the same time.
So we have covered a ton of ground here. The theory, the tools, the traps. Let's boil all of this down into a simple, actionable playbook that you can start using to speed up your deployments today.
Here are your 5 key takeaways. 1. Always start with your code. Clean it up, minimize those dependencies. 2. Carefully experiment with the -parallelism flag. And remember that the default is 10. 3. If you've got a massive codebase, seriously consider splitting it up. 4. Always be aware of external limits like API throttling. And 5, probably the most important, test your changes. As we just saw, more parallelism is not always better. You see, understanding and controlling parallelism, it takes you from just writing Terraform code to truly engineering your infrastructure deployments for speed and efficiency. That power is now in your hands. So the only question left is, what are you going to build next?